This video is on solid of revolution, and so here I have this yellow region right here, and I'm going to revolve it about the x-axis, and we get a solid of revolution, and I want to find the volume of the solid. And so this is the region that we want to revolve about the x-axis, and this region is bounded between the graph of f of x equal to 2 times the square root of x, and the x-axis from 0 to 9. And so now let's revolve it about the x-axis right here. And we get a solid of revolution that looks like this. And then to find the volume of this solid of revolution, what we can do is we can divide the solid into thin slices like this. And then each slice or each disc will be in the shape of a cylinder. And what we would do is find the volume of each cylinder and then add them all together, and that will give us the approximate volume of the solid of revolution. And so this is one of the discs or one of the slices, and so let's call this the ith slice or the ith disc, and let's find the volume of this ith disc. Notice that the distance from here to here is 9, and so if we divide the solid into 9 slices or 9 discs, then the thickness of each disc will be 9 over 9, which is 1. So it would be 9 minus 0, and then dividing by the number of discs, which is 9. Then the thickness of each disc will be 1. So this thickness right here will be 1. But if we divide this solid right here into 90 discs or into 90 slices, then the thickness of each slice will be 9 over 90, which is 0.1. And therefore, in general, if there are n number of slices, then the thickness of each slice will be 9 over n. And let's call the thickness of each disc or of each slice, let's call it delta x. And so here's the ith disc again with the original graph. And so the ith disc, the middle of it intersects with the x-axis right here at this point right here. And so let's call this t sub I, since this is the ith disc. And so right in the middle of the disc, let's call this t sub I. Then notice that the f of t sub I would be the distance from the x-axis to the graph. And that's what f of t sub I is. And so in this case, f of x is 2 times the square root of x. And so f of t sub I would be 2 times the square root of t sub I, which is the distance from the x-axis to the graph at x equal to t sub I. Now f of t sub I in this case is also the radius of this ith disc. The volume of this disc or of this cylinder is pi times the square of the radius times the height of the cylinder. The radius of the disc is f of t sub I squared. The height of this cylinder is also the thickness of this disc. The thickness of the disc we denote it as delta x. And so the volume of the ith disc for this ith disc right here will be pi times 2 times the square root of t sub I squared times delta x. Now we divide the solid of revolution here into n number of disks or into n number of slices, and then the volumes of n disks or n slices would look like this. This would be volume of the first of slice number 1, volume of slice number 2, and volume of nth slice. And using summation notation, we would write it like this. It would be the sum from with I running from 1 to n. And then right here we can simplify the 2 times the square root of t sub I squared, be just 4t sub I. And so this is the volumes of n slices or n disks. And so the volume of the solid of the revolution right here would be approximately equal to this sum. Would be just an approximation of the volume of the solid. Now if we want the exact volume of the solid, then we need to divide the solid into an infinite number of slices, meaning let n run to infinity. And then with n running to infinity, we would write it like this. It would be the limit of this sum right here with n approaching infinity. And then if this limit right here, if it exists, then we would define it as this definite integral from 0 to 9 pi and then f of x, which is for the radius squared, and then dx right here. And then the 0 to 9, because right here for the solid, this solid of revolution, x runs from 0 to 9. And f of x is 2 times the square root of x, and then 2 times the square root of x squared, it just is 4x. And then the 4 pi, we can move it and place it in front of the integral right here. And then the integral for x is just x squared over 2, and then evaluating from 0 to 9. So when x is 9, we get 81 halves, and then when x is 0, we just get 0. And then simplified everything, we get 162 pi. And so the volume of this solid of revolution, the exact volume, is 162 pi. And that's the end of the video.